Hi, my name is Sri Harshita. My topic is on network topology basic definitions. So, first, what is network topology? Network topology is arrangement of various elements, links, nodes, etc. of an electrical network such that there is no distinction between physical types of physical elements of network. Why, ne- why we need to learn network topology? When a circuit is non-planar or complicated with large number of nodes and closed path, then conventional methods like KCL, KVL, nodal analysis, mesh analysis, etc. becomes highly difficult. Analysis of such networks can be done conveniently using network topology. Where we do apply network topology. Network topology is used to analyze voltage and current across various branches of an electrical circuit, more particularly complicated circuit. So basic definitions are node, essential node, branch, loop, mesh and graph. So here it is the node, circuit illustrating terminologies. A node is a point in a circuit where two or more circuit elements join. The number of branches incident to that node is the degree of its node. At 07, A, B, C, D, E, F and G. Then a node that joins three or more elements. At fourth point, B, C, E and G are joining. And branch, then next one is the branch. Branch A, single path containing one circuit element that connects one node to other, and it is represented by solid line. And here the value 10 represents the V1, R1, R2, R3, V2, R4, R5, R6, R7 and I. And the next is the loop. A loop is a closed path, that is, it starts at a selected node, traces a set of connected basic circuit elements, and returns to the original starting node without passing any intermediate node more than once. At level A, B, H, I, K, J, Z, F, C, A, comma, A, B, H, I, G, F, C, A, comma, A, B, different types of nodes or loops are formed at level. And the next one is the mesh. Mesh is a special type of loop which does not contain any other loops with it. And there are some definitions that are graph, oriented graph, rank of a graph, planar and non-planar graph, tree and twins, chord tree and links or chords. So the first one is a graph, oriented graph and rank of a graph. A graph corresponding to a given network is obtained by replacing all circuit elements with lines. And rank of a graph means if there are n nodes in a graph, then rank of a graph is n minus 1. And then oriented graph. If each of the line or branch of the line has a reference direction as indicated by an arrow mark, then the resulted graph is known as oriented or directed graph. The step for a drawing oriented graph. First, replace all resistors, indicators and capacitors by line segments. Second one, replace voltage source by short circuit and current source by open circuit. And third one, assume directions of a branch currents. And finally, name all the nodes and branches. Here are the some diagrams. First one is the circuit, and then it's graph, and then it's a directed graph. So three topologically equivalent graphs. The next, here A, B, C are the first one is the circuit, and B and C are the directed graph. The next one is the planar and non-planar graph. So planar graph means a graph drawn on a two-dimensional face is said to be planar if two dimensions do not intersect or cross at a point which is another than a node. Then it is known as planar graph. And non-planar graph means a graph drawn on a two-dimensional plane is said to be a planar if two branches intersect or cross at a point which is other than a node. And next one is the path and the subgraph path. So the path is a set of elements that may be traversed in order without passing through the same node twice. And second one is the subgraph. It is a subset of branches and nodes of a graph. It is a proper subgraph if it contains branches and nodes less than those on a graph. A subgraph can be just a node or only one branch of the graph. And here figure A is the graph and B is the proper subgraph. Next one, tree. A tree is a connected subgraph of a network which consists all the nodes of the original graph but no closed path. The graph of a network may have a number of trees. The number of nodes in a graph is equal to the number of nodes in a tree. And the next one is here are the examples for tree. These are the trees for the given first diagram. We can draw different types of trees. We can draw n number of trees. And the next, tree and twigs of a graph. Tree and twigs, a connected subgraph having all the nodes of a graph without any loop is called a tree, and branches of a tree are called twigs. Properties of tree. There exists only one path between any pair of nodes in a tree. A tree contains all nodes of the graph. If n is the number of nodes of the graph, there are n-1 branches in the tree. Tree do not contain any loops. Every connected graph has at least one tree. The minimum terminal nodes in a tree are 2. And next one, the branches A, C and E are the twigs, while branches B, D and F are links of the tree. It can be seen that for a network with B branches and N nodes, the number of twigs of a selected tree is n-1 and the number of links I with respect to this tree is B minus n plus 1. The number of twigs n-1 is known as the tree value of the given graph. It is also called the rank of the tree. And here is the graph. And second is the twigs. I have 1, 4, 5 are the twigs. And 3, 2, 3, 5 are the twigs. And the next here, so identify trees in the graph. So here they given a graph and we have identified n number of trees from this tree. 1, 2, 3, 4 is another tree. 1, 2, 3, 4 or any by using 1, 2, 3, 4 we can draw n number of trees. A tree does not have a closed path and graph must and should have the closed path. The next trees and graph. For the given graph, tree in the sense A, B, D are the trees A, B, D and link of the code tree. The links of the code tree are C, E, and F. The next another one A, D, F are the twigs of a tree and another is the twigs of the code tree is the C, B, E. So these are the basic definitions of the network topology: mesh, node, tree, graph, and graphed, and etc. These are the basic definitions of the network topology. And